So anyway, today, what I want to get at today, I gave you guys a tape measure. I want to wrap up linear modeling, and then we're going to go outside and collect some more data for the next kind of modeling, and you'll see what that's all about once we get back inside. You brought warm clothes, right? I warned you. I think I warned you. Yes. Pretty sure. I did warn you. Okay, good, I did. So, what I want to do though is, I was telling my, my stat classes this yesterday, math for the sake of math is dumb. Math, it's a human creation, really. I mean, things happen mathematically, but we kind of sat down and made rules out of it. So math for the sake of just doing math is like, I play drums only because I can sit down and play paradiddles. I don't do that. I play drums so I can play music, so I can write songs, so I can perform live. So math should be used to do something, in my opinion. I mean, sure, you can sit down and do math puzzles if you like doing that kind of thing, and that's fine. So somebody made a claim to me years and years ago, and a few of you asked, because you watched the solution videos to one of the quizzes last week, you mentioned something, this golden ratio quiz. And I realized I did the quizzes in a slightly different order this year, this term. I'm going to have the golden ratio quiz for you guys posted next week, because we hadn't mentioned it in class yet. So I want to make sure, who's heard of a thing called the golden ratio, or the golden section, or the Greek letter phi? I'm going to do a real, thank you. I'm going to do a real quick Google search here. Do a real quick Google search, and the golden ratio is a special number. How many of you have ever heard of pi? The number pi, yes, there we go. How about the number e in mathematics? Ooh, oh good, quite a few. Yes. What's pi about equal to?
3.14.
Ah, yes, we have that. Easy. It's amazing. If you do any more than 5 digits of pi, the precision is imperceptible to the human condition. It's crazy to think about that. Like if you think about like a tire that has to be round, any more than 5 decimal digits, and it's the payout that you get back from making it that more precise is immediately negated by how much it would cost to make it that round. Not to mention the fact that as soon as you drive on it down the street, it ruins it. Because that level of precision, the 10,000th of an inch, is going to get eroded away immediately. So, very good. So, what's E equal to? E. Ah, yes. Yes.
Is that the Greek E?
No, just the letter E. It's named after Leonard Euler, one of the great mathematicians back in the day.
Is it between 2 and 3?
Nice! It is! Okay. It is 2.7, 1828, 1828, blah, 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 something or other. Good, very good. The golden ratio is one of those numbers too. It's one of those numbers too, golden ratio. So that's what its approximate value is. You don't have to write this down. I got a whole quiz based on it for next week if you want to take it in then. Also, the quiz also shows you where it comes from mathematically. But what I'm more interested in is, why do we call it the golden ratio? What's so special about that number? What's so special about that number? Now, Josh.
It's kind of everywhere.
You guys have a tape measure in front of you, yes? If you have a TI in front of you, would you be so kind to measure the dimensions of the screen of your TI and then divide the long dimension by the short dimension? Okay, I'm going to turn the camera off while you do this. We'll do a little experiment here.